Hello and welcome to another in the series Talking with Dan Gibson. If you have questions that you'd like to ask after you see this video, please write me at dan@canbooks.ca. It's written on the bottom of your screen. So far, we've been talking about three different books. Books that I wrote over a period of time. This book, The Nabataeans, was written back about 2003, 2004, about the Nabataean people, and it came out back then, written for not an academic audience, but a popular audience. That was followed by this book, Quranic'geography, and it covers the geography of the Quran, looking at the people of Ad, the people of Thamud, the Midianites, and so forth, and it introduces the idea that Mecca, the city of Mecca is in Saudi Arabia, is not the original founding city of Islam, but rather that all the Qiblas pointed to Petra. And a lot of people were very interested in that topic, and so that book was there. It was followed up by the film, which was called The Sacred City, and people asked for the information behind the film, and so that's when I produced this book, Early Islamic Qiblas. And this book looks in detail at the early Qiblas, and that whole information. Was the original founding city of Islam, was it the city of Petra, or was it the city of Mecca? And where was Muhammad born, and how do we know which one is which? So that's this book, 296 pages. It's a large format book in full color all the way through. Now, this book was originally 8 academic papers written on an academic level. And so as we go through it, there are 8 different sections. The very first section is called Early Islamic Qiblas. And it contains a database of over 60 mosques from the first 250 years of Islam. I've traveled all over the world and tried to visit each of these mosques, and those I couldn't visit, I checked our archaeological, on all of them I've checked archaeological records, and sometimes I've had to ask somebody else, could you visit this mosque, and so forth, in order to get accurate GPS recordings, or at least visit the site and get the data that I need for each of these mosques. So there is a database of over 60 mosques, and I did not pick and choose the mosques. This is a list of all of the mosques that I could find, every last mosque from the first 200 years of Islam. I've been hunting for them, and perhaps you're aware of a new mosque. Please let me know. One of the challenges is, if they're not famous mosques, if they're rather, off in some corner somewhere, how do we know how to date the mosque? That is always a challenge. So I'm always interested in learning. If you know of a mosque in your area that dates back to the beginning of Islam, please write me, dan@canbooks.ca. I'd love to learn more about the mosque in your area. Now, you will discover in this book a chart, and I discover as I look at these 60 mosques that during the first 100 years of Islam, all of the mosques faced Petra in Jordan, not Mecca in Saudi Arabia. And so you will see this is a timeline, 1AH, it's starting. This is after the Hijrah, the first years of Islam. These are Islamic dates. Over 100 years, mosques pointed to Petra in Jordan. Then something that history doesn't tell us clearly. We have to go digging to find out what happened. But those first mosques, they are pointing to Petra with an extreme accuracy, less than 2.5 degrees in accuracy. That's the average accuracy. Some of them are within 1 degree of pointing at Petra. I mean, they're very, very accurate. Then we find 3 things that come. There are mosques that point to Petra, mosques that point between Petra and Mecca, and mosques that point parallel to a line drawn between Petra and Mecca. And so the Mecca mosques, they're actually very few at the beginning, starting 100 years. It's 109 years after the Hijrah when we find the very first mosque that we can say was originally built, pointing to Mecca in Saudi Arabia. And there's only 5 mosques that we can draw this data from. There are 8 mosques that point between these two, and they were all influenced by a man by the name of Hajjaj, General Hajjaj. And he refused to accept Petra, he refused to accept Mecca, and so he decided, I'm just going to point my mosques right in between the two. Very interesting. And then there are the parallel mosques, and these all come from North Africa and from Spain. So notice the accuracy of the mosques. This is a map of the area around Petra. Only 2 of the Qiblas lie outside of a 75-degree circle, which is 45 miles, or 75 kilometers around. 2 Qiblas are outside of that circle. Many of the Qiblas are less than 20 kilometers from Petra. And when you figure out that some of these are pointing from Iran and India, and one from China and so forth, this is staggering that they are this accurate. And some are extremely accurate. And so for every mosque, when I have studied them, I've written them up, I present a chart for each mosque. Here's the chart for a mosque. And so we show on the left, starting on the left, the actual mosque points to 304 degrees. And so that's where that mosque points, from visiting the mosque and from taking accurate readings. The Petra is 304.06, so we're out by, that's the next column, 0.26 degrees, so it's very accurate. Mecca, however, is out by 75 degrees, and then Jerusalem is out by 1.65 degrees. I always try to include these others so you can see, well, where exactly is this pointing? These charts are done up for all 63 mosques in the book, explaining what's there, what's parallel, and so forth. Now when we get to the second section, we ask the question, what is the accuracy of Google Earth? Many people have asked me this. Oh, look at this map from Google Earth. How accurate is this? Well, first of all, people who read this are assuming I use Google Earth for the measurements. It's not true. I use Google Earth to confirm the consistency of my measurements. I use Google Earth to illustrate, chart, and map the things that we're doing. But Google Earth is not what I based this research on. Google Earth has problems, and we talk about this in the second section. For instance, the screen resolution. If you're using a small window from a cell phone, or if you're using a big one, the screen resolution changes. Every time you zoom in, the resolution changes. Every time you move over, you start changing maps because Google Earth is made up of one map overlapping another map and so forth. So real challenges because they took round maps, square maps, and they put them on a round surface. And so some have to be shrunk, and some have to be twisted, and some have to be overlapped and fit together and so forth. So Google Earth is not the best way to do the research. It's not very accurate. Rather, I preferred to use the Japanese Advanced Thermal Emission and Reflection Radiometer, or ASTER as it's called. The entire Earth is mapped by the ASTER satellite every 2 to 3 days. It takes a stream, a photo that is a long stream. As it's going along, it's just taking pictures of the Earth. It takes 260,000 photos every 2 days. And the reference points are just 96 or 98 feet apart. And so it's very accurate, and you need to ask for permission and explain why you want to use their data, and then they give you permission, and then you have access to this data. It's a much more accurate picture that's been taken of the Earth and of the entire surface of the Earth. And so that is the data I would use to double check the measurements that were taken on the ground. Or in the rare case where I couldn't visit a mosque because it's in the middle of a current battle or something is going on there, then I have resorted to using ASTER and taking measurements from that. But that's very rare that I do that. I prefer that someone actually visit the site and take a GPS and check the data as well on the ground. Section 3 talks about obtaining Qibla calculations when you visit someone. How do I measure when I'm on the ground? When I visit a mosque, what do I do? And so I talk about, I get maps of the area. I get the archaeological reports of the area. I then establish points for the calculation, and you have to set up these different waypoints. And then I measure the GPS. From outside the building, perhaps inside the building. If the building's still standing, you have to use the outside of it. And so you need to go in and find out, where was the Qibla wall? Some of the earliest buildings do not have a mihrab or a niche on it. So you need to go in and find out which wall is the Qibla wall. And then outside the building, then you can take your measurements, or if the building is just a set of ruins, then you can do them right inside because there is no ceiling above you. And then measure that with other things, and take all these measurements and put them together. And if I need to, I use parallel measurements. When I was in China, there is a roof on that building. So when I came out and took the measurement on the wall, I noticed that they had huge cement square tiles, a whole courtyard out there. And I realized I could just go over 2 or 3 lines and I get a straight shot up to the sky with the satellites, and then I could take a measurement down that line and get that exact measurement. Now that I can see from space. Looking down this building, I could see the building. I could line up the building, but it had overhangs of the roof on it because it's a Chinese structure. But I could measure these lines outside and realize these lines run exactly parallel to this side wall, and I could do my measurements that way. But you've got to visit. You've got to look at the building. You have to decide, how do I know that this is the Qibla wall, and how do I get the right measurement? Don't use a screen. If you have to use a screen, if you want to double check and use a screen, when you go to the screen and you're looking at something and you see a building, imagine this is a building here, and this is the Qibla wall. What I would do is I would take a line in Google, you can do this in Google Earth if you want, draw a line parallel to this, a much larger line that is exactly parallel to this end, because it's so easy to get them off. So get a line that's parallel, and then on your screen, take something, maybe a white piece of paper, and put it over here on that line so it follows it, and then draw a line this way, and then look at the measuring tool that's there and get the exact degrees, and then pop that line that degree, and now you can check which way the Qibla goes. So, but make sure that you are exactly working off of the Qibla wall, and then getting a line that goes 90 degrees from that wall. So talking about how do we get the Qibla measurements, and don't just do something haphazard. The largest screen you have is the best screen. Section 4. This was about the Qibla misunderstanding. And why do modern scholars assume the ancients could not accurately determine the Qibla direction? And there are several reasons. One is that we are told by the medieval Muslims, oh, those guys got the Qiblas all wrong. And why is that? Because they were looking at the Qiblas that were parallel, the Qiblas that were between, the Qiblas that pointed to Petra, and they said, oh, those are also inaccurate. They didn't know what they were doing. It's only when we did a complete survey of all of the mosques that we begin to recognize the patterns in the data. So modern scholars also have not gone around and measured the mosques. Up until about 20 years ago, this would have been a huge job to visit a mosque. Even in when you go to the Citadel in Amman, Jordan, and you go to the mosque that's there, the guys who were the archaeologists who were there, they wrote up their reports before the time of GPSs. I started, as soon as GPSs came out, I grabbed these and started using them. But they were using the old method of looking at the stars and looking through it and adjusting, and they got their measurements off. So we have to be careful with some of the earlier ones, but we go back and look. So the scholars writing over the last 100 years, they assumed the earlier writers were right because to do all the checking was impossible. Only in the last 20 or 30 years have we been able to actually use modern technological tools to do the checking using the satellites that are up in space. And also in the past, they assumed that there was only one way to establish the Qibla, and that was to use mathematics. And they assumed that the Arabs of earlier times didn't have a mathematical ability to do this. And of course, the last reason why they thought that the earlier Qiblas were wrong is that some Qiblas that were set during the Middle Ages were wrong. And so they would point to, well, look, that mosque is wrong and that mosque is out. So obviously the earlier people, they didn't know what they were doing. In this book, I present a chart, and it talks about the earlier times, which is what the people writing about talk about the folk methods. Its knowledge disappeared over time, and then the mathematical ideas came into being, and then they have phased out because of the modern navigational tools that we have, GPSs and so forth. So the earlier methods were lost. And why were they lost? Because the armies that were marching in the desert at the beginning were using the stars for navigation. But once they entered into the areas of the Roman Empire and the Babylonian Empire and so forth, they came onto Roman roads, and Roman roads had milestones, and you could follow the road, and there was the milestone, and it told you exactly how far it was to the next city. So they lost their ability to measure the stars. And very quickly, they no longer needed that, and so it became lost. And so that's one of the reasons why the earlier methods disappeared, and it's taken some detective work to try to figure out how did they determine the Qibla in the earlier days. And that's the topic for section 5. This is called, Could the Arabs of the 7th and 8th century accurately determine the Qibla direction? And I spent 7 years researching this topic, trying to figure it out, and looking at the whole area of astronomy versus astrology. Two different things. Astronomy is the study of the stars, and from that you get the science of navigation by the stars. But most of the early civilizations, they were interested in astrology, trying to tell the future by using the stars. A very different way of approaching the stars. So the Arabs in the desert, they needed astronomy. Because for those camel caravans, remember they're crossing the deserts of Arabia, and so they need to know Mesopotamia is there. I want to go to Babylon, I go there. I want to go to Gaza, I need to go there. I want to go to Cairo, or Alexandria was the main port. I want to go to Alexandria, it's over there. And so Damascus is there. How would they tell where those cities were over the horizon? Their interest was looking over the horizon. They were not interested in mapping the world. They were interested in simply finding a location on the horizon. So the horizon was very, very important. Now, a lot of the materials that I've got out of books, and I've got a pile of them here on my bookcase, and I've been hunting away different books that were written, many of them written hundreds of years ago, and have been translated, some of them into English, and some of them are still in Arabic. But as you read them, there's a system that evolves of how they could navigate, how they could look at the stars. For instance, they measured the North Star. To tell their way north and south was very easy. The North Star was up there and it didn't move. And so if you were at your location, you would measure using your fingers in front of you, and you could measure from the horizon up to the North Star. You measured that in fingers, Isba, and in Zam, which were the 8 little breakdowns of the number of on your finger. If you weren't sure, you could use a block of wood. They would have a block of wood that they would slide on a string, and they could measure the height of the North Star, and that gave them an idea. So they used this. That block of wood was called a kamal, or for where we get our word camel, but a kamal. And so they understood these lines of Isba, and they were very clear in their mind all the different cities and how far north and how far south they were. On the screen, you're seeing a map of the Red Sea, and on the side, it shows us the lines of Isba all the way going up. This is not, and this where people get confused because they're thinking in terms of latitude and longitude. This is not latitude and longitude. This is the height of the North Star. Now, they had the height of the North Star. How did they tell east from west? Well, they had several ways of doing this. First of all, for the Arabs, the important thing was not time, but rather distance. The British used time to measure when they were doing latitude and longitude. And so they couldn't actually do their measurements until they got accurate clocks. And they used the time that it took the sun to move across the sky, and that's how they calculated their calculations. However, the Arabs didn't have that, so they couldn't use time. So they needed a constant. They needed something they could measure from. And what they decided to use from way, way back in history was to use the number of steps a man took to walk. You see, when the camel caravan was crossing the desert, the men walked and the camels carried the load. Men didn't ride unless the camels were empty. The men walked and the camels carried all the weight of all the things they were taking from place to place to trade. And so they kept track of their walking. And we find this in the Romans talk about it. Other historians talk about these crazy Arabs. You know, it's 6,240,000 some steps, you know, from Qataban down in Yemen all the way up to Gaza. They knew the number of steps. Why did they know that? Because that was an important part of counting their steps. So they knew the distance they had traveled. They also knew the distance that the height of the North Star was. And there was more things. Well, first of all, let's go back to the distance. I tried this with my sons. We measured it, and it worked out okay, but we had a repeated problem over and over again. We would be counting, and we would lose track of the number. You know, 1,444, 1,445, 1,000. I mean, it's hard to count. The Arabs had a much simpler system. They had poetry that they would recite. And as they walked along, they would recite the poetry, and each step had a beat to it. And this was a rhythm that they had in the early writings. And so whatever they were saying, they knew it. And so there was a number associated with each of these poems. And so when they had walked to the end, they knew the number of steps they had taken. This is where the concept of the singing caravan comes from. The Arab in the desert who begins chanting as he is going along in the desert, because he's keeping the rhythm and he's measuring the distance. Now, over time, they lost the art of measuring the distance. They didn't need to, but they still kept up with that rhythmic song that they sung or recited as they went along. And so you have the singing caravans keeping track of the distance that they had walked. Now, there's something else, and we point this out in the book. It is the Arab compass, because they had 32 stars, which were very important. Remember, everything works off the horizon. You're out in the desert, it's flat. You have a horizon. And on the horizon, they noted stars that would rise at different points in the horizon, move over the horizon and come down, and those would set over here. Now, in the Arab calendar, compass, in the Arab compass, they didn't have 360 degrees like we have. That's a Babylonian thing. They had 224 degrees. And it worked out very well. It's a very nice calendar. And so they had these 32 stars that rose, went over, and set. And so they used this all the time, wherever they were going. They were measuring, and they knew the direction on the horizon. We explain a lot about that in the book. And so many times you're reading an Arab book, and you come across something that sounds interesting. He'll tell you, walk along Naqqa. Okay, and you think, what's Naqqa? Naqqa is a star, and you know where it rose in the on the horizon, and therefore you're walking along. There's the North Star. Naqqa is there. You see where it rises. You're to walk towards Naqqa this far, so many steps, and then you're to take another direction. And so they used the stars that were on the horizon to give direction in which they were going. So we have lots of things in the book, lots of different ways that they could tell the direction. Lunar values, lunar times, lunar mansions, often the things that are misunderstood in the West. Lunar eclipses. you know, they last only a few hours. Solar eclipses might be only a few minutes, but if you're in one place and you see a solar eclipse, and that happened at noon, and these guys over here, thousands of miles away, they knew it happened in the evening, and you talk to each other, you can figure out distance using solar eclipses. What's interesting, during the reign of Emperor He of the Han from China, around between 90 and 100 AD is the time that he ruled, he sent out explorers. They went over to where the Arabs were, and they brought back jugglers, musicians, and learned men, brought them to China, where they brought their knowledge to China, and then those men that went there, the Arabs that went there, went back home. During that time, there were solar eclipses. And so by remembering where they were in the sky at what time, and then telling that story at home, and the men at home said, no, it wasn't that time, it was this time, they could recognize the distance between China and the Middle East, a value known very early in time. We're talking within 100 years after the time of Christ. These men had gone back and forth in visiting. And we have charts in the book of all the different times that Chinese visitors visited over in Arabia and so forth. So we have this connection between the two. So is it any surprise that it was the Arabs who went to China to trade and not the Chinese who came to Arabia? And so there's this continual moving. Soon after those guys went to China and recognized where it was in the distance, soon after that, boats set out from the Arabian Peninsula straight across the Indian Ocean to China to reach them to begin their trade. We look at the astrolabe and how it's used. We look at Pythagoras' theory, and it was well known at this time. We look at something the Arabs called ishrat, or a local guide, such as mountains and how they use the mountains. We look at the Arab compass and at the Portellan method. We even look at pigeons, because you can release pigeons and they'll head straight home, and they can do that up to 1,000 miles. It's easy to use homing pigeons to tell direction. Just bring a homing pigeon from one city to another one, let him go, and you know where he went back. So that's section 5. Lots of interesting information of how you could set the direction of a mosque back in those days before they had mathematics. The last section, section 6, asks the question, when did the Qibla change take place? You see, it was originally Petra, right from the beginning. And then we show that Ibn Zubair, in 65 years after the Hijrah, long after Muhammad is dead, he's the one who destroyed the Kaaba. He rebuilt it in Saudi Arabia. And that's when the Mecca Qibla started. 87 AH, you get 87 years after the Hijrah, a few years after Ibn Zubair destroys the Kaaba in Petra. General Hajjaj, he's the one who is sent down. He attacks Petra. He destroys that. He defeats Ibn Zubair, and he disagrees with the new, the Black Rock, which has been moved down to Mecca in Saudi Arabia. He doesn't like that. He doesn't like the old one place because it's all full of pagan temples and it's been destroyed. So he decides to point his mosque between the two. And we have those between mosques, and then finally the parallel Qiblas, which were developed in North Africa and Spain. It's all in the book. At the end of the book, there are 25 supporting evidences that support this theory that we put out there. And then there's another chapter of a further 25 supporting. So 50 different evidences that support this whole thing together. So it's an interesting book. It's got bibliography behind it and index at the back. So there are 3 overlapping books. The Nabataeans, Builders of Petra, at the beginning. There is Quranic'geography, the geography of the Quran. It introduces the idea of the Qibla change. And then there is early Islamic Qiblas, and it brings it all together, the Nabataeans, the Qibla change, and how it all happened. It's all here in these books. And you can find these on the internet. You can find them as PDF files that you can purchase and download and have like a book and you can read on your screen, or you can go to Amazon or one of these online booksellers and find the books there and purchase them. Because it's hardcover and because it's an academic book with full of all kinds of colored pictures and photographs and maps in here. This book is quite expensive. You'll have to pay for it. But we've made the PDF as cheap as we can, $15, so that people can get a hold of it and have the information and check it out. This is a big surprise for many people because the history of Islam is very different from how we've understood it. So please, Dan@canbooks.ca. Use that address, Dan@canbooks.ca, and write me if you have further questions. I will try to answer. I may turn it into a YouTube video if it's a very good question. So thank you for watching another video on the series, Talking with Dan Gibson.